Palace. All right, that's what I always say now. Mine is Palace. All right, so number 86, we'll do that one. So, guys, one of the things that the other class was getting confused on last night, this will be good for Leighton because he didn't see it yesterday. He should have already raised his hand like 4 times. But one of the things that they were confused on is with this red angle here. What angle do you use when you create the reference triangle? Well, you drop your altitude down, you get a 90, and then you've got your X, your Y, and your R. So which angle are you using? You're not using the whole angle, you're using the reference angle. First of all, you couldn't use the whole angle because it's bigger than 180. What's the total degree measure in a triangle? It's 180 degrees, so you can't use an angle that's bigger than 180. And on top of it, this angle's negative because you're going clockwise. It's like a negative 225. But what you can do is understand that there is a reference angle that will produce the same trig values because it doesn't matter. I remember I said standard, when you're in standard position, you're measuring from the positive x-axis. But that was just because some mathematician that's dead now decided to do that. He could have decided to measure from the negative y-axis. The reference angle is still the same thing on either side. So this is still coterminal. They're still terminating in the same location. We're just using the reference angle, which is just how far the terminal side is from the x-axis. Quick question.
Oh, when we got like a big number and a square root, you want us to simplify that?
I do. And you won't have a calculator. But I won't make them that big and ridiculous. Okay, I'll make them pretty realistic. Probably less than 200. All right, so when I do this, it could have been this angle. It could have been this angle. All of those angles have the same reference angle. Therefore, when you create the triangle by dropping your 90, you're going to get the same triangle with the same 6 trig ratio values for all those angles. There's an infinite number of angles that will have this same triangle, which will produce the same 6 trig values. So just use the reference angle, because all those angles that are coterminal here have the same reference angle. Does that make sense? Any angle coterminal there is going to have the same reference angle and will produce the same trig values. Now, a lot of people are getting confused. What's a trig value? Trigonometry was created so that you could relate x, y, and r. See, before trigonometry, the only relationships you had in a triangle, the Pythagoreans first discovered the Pythagorean theorem, or some people say it was actually the Chinese and they came over and introduced it to the Pythagoreans, but who knows, which wouldn't surprise me. X, Y, and R, okay, because a lot of people were, traveling around the world at that time, and wouldn't surprise me if there was other influences and it wasn't just one set of people group that discovered the Pythagorean theorem. But at that point, they only knew that x squared plus y squared equals r squared. Remember, I always want you to label this one x, this one y, and that one r. Here's your reference angle theta. So we're just going to use that little angle there. Okay? Now, what are the trig ratios? Well, again, up to that point, they only could relate x, y, and r. They also knew that there was 180 total degrees in the right triangle, or in a triangle period. And so those were the only relationships they had. But then trigonometry came along, and they started studying triangle measure, and they said, oh my gosh, there's this relationship between the angle and the sides of the triangle. And that relationship that exists between the angles and the sides of the triangle is where we get our trigonometry. Now, it would take me hours to prove to you how they actually calculate sine. When you type sine of 2 in, do you know how they got that decimal? You have no clue. And it's about 3 pages of notes for me to show you how they get that, because it takes Calc 2 and Calc 3 to be able to do that. For example, logs. How many of you, when you typed in natural log of 5, you knew where that decimal came from? No, if you want to figure out natural log of 5, you took your calculator and said, you took your calculator out and you typed in natural log of 5, because you don't know how the natural log is being calculated. You just know what it is. You just know it does something. Same thing for sine, cosine, and tangent. So when I do the sine of an angle, sine's doing something that angle that makes it equivalent to the opposite over the hypotenuse. Cosine is doing something to that angle that makes it equivalent to the adjacent over the hypotenuse. Tangent is doing something that makes it equivalent to the opposite over adjacent. And then we created the secant, cosecant, cotangent as just reciprocals of the first 3. There's nothing special about that. We just flip them. Okay? So that's what trig ratios actually are. Now, what I want you to know by tomorrow, hint, hint, You need to make sure you know sine is y over r, cosine is x over r, tangent y over x, cosecant r over y, secant r over x, and cotangent x over y. Because no longer do we need to just define it as opposite over hypotenuse. You need to know what the trig ratios are defined as in terms of x, y, and r. Now some of you are like, well, what if I forget? Draw a triangle again. Draw a little theta, draw your x, draw your y, draw your r, and say, okay, sine, opposite, hypotenuse, y over r. Cosine, adjacent, hypotenuse, x over r. Tangent, opposite, adjacent, y over x. Simple to remember. If you forgot, you could just go back and prove it yourself. Now, since I have x, y, and r, what is x happen to be for this particular angle? Happens to be negative 2 root 5. What does y happen to be? And it does matter if they're positive or negative, because that's going to tell you which quadrant it's in. What's r? Don't know. Can I find r? Pythagorean theorem. So I'm going to take negative 2 square roots of 5, square it, plus 4 squared equal to r squared. What are you going to get when you square negative 2 roots of 5? You got to square the negative 2 and the root 5, so you're going to get 4 times 5 plus 16 equals r squared. So we're going to get 20 plus 16 is equal to r squared, which is going to give me 36 equal to r squared. What's r equal?
6.
You certainly don't have to show all that work. So r is 6. Still good. Now I can find any ratio. So I can find, let me just kind of go through some of these because this is what you're going to do in your homework tonight. In fact, in your homework tonight, they're just going to say find all 6 trig ratios. They're just going to tell you what the point is. You're not even going to be given a diagram. Do you really need the diagram? No, because you know it's always a right triangle. So just write down x, y, go find r, use Pythagorean theorem. You don't even need to draw the triangle. Okay? So once I get that, I can find any trig ratio. I can start with sine. Sine is what? Y over r. What's y? 4. What's r? 6, which is 2/3. Bam, done. Cosecant's just the reciprocal of that. So I can shortcut cosecant just by doing what? Flipping sine. Done. That's what the sine of theta equals. That's what the cosine of theta equals. I'm going to do one more because I want to show you something. I'm going to go back and do the problem that I did for them this morning. What else? Cosine. Cosine of theta is what? X over r. What's x? Negative 2 root 5 over 6. This reduces. What does it reduce to?
Negative root 5 over 3.
3. There you go. Done. Now you can do secant. What's secant going to be? I'd flip the one that's reduced.
Negative 3 root 5 over 5.
Negative 3 over root 5, and then you do have to rationalize the denominator. So rationalize, you got to multiply the top and bottom by root 5, so you're going to get negative 3 root 5 over 5. Could you do tangent? Tangent, cotangent, you don't even need r. You just need y and x. That's kind of nice. But you could do those as well. Any questions there? All right, makes sense. Yeah, I'm going to stop the video and I'm just going to do one more thing for you guys.